So let us see how to find a square root. To find square root, we have long division method, and the other one we have is a approximation method, right? Long division method will give you a perfect answer, but it takes time. So approximation method is more suitable when square root is a part of some question. If you are doing a mathematical problem only of a square root, please do it with a long division method. You will need an accurate answer, right? The question is for the square root. But in physics, square root is a part of some questions, and it becomes very tedious, very time consuming in order to find the square root. So the best is to approximate it, right? You will get the correct answer. Some values may differ after decimal point, but it's okay. It is considered right. It will save time. So square root through the approximation method. Let's take an example. So the first example I'm taking is, let's say I want to find out the square root of 449, a 3-digit number, right? So to identify its square root, right, you must be having a knowledge. You must be knowing the square root of 1 to 20 numbers, or maybe 1 to 30 numbers. It's good. Even if you do not know, let's say you multiply and identify. 4 is the first digit, so I'll try it with the 20. So it gives me 400. So now I can clearly identify that 400 is close to 449, right? So square root should be something after the 20. Let me try it with 22. So 44044. So it is 484, bigger than the 449. Let me try it with 21. 441. 21 is a very close number, right? 441, and it is 449. So this square root approximately you can write it as 21.1. Even if you write it as 21.2 and use it in your calculations, for sure you'll get the correct answer. Let us take another number. Let's take a 2-digit number. Let's say you are required to find out the square of 32, right? So I know that the square root of square of 5 is 25 and square of 6 is 36. So this number is close to the 6, more than 5 and closer to the 6. So I'll take it as 5.7, or you may also take it as 5.6, or if you take it as 5.8, all three of them will get you your non-decimal values, your integral values correct, but some values after the decimal point will change. As I said, the change in the values after the decimal point, it's not going to harm your final calculations, right? At higher level, that is 9th standard, 10th standard, 11th and 12th, such approximation, if you use, your answers are little bit varying in decimal point, but it will save your time and will give you a very close answer. Let's take the example of a 4-digit number, 3321, right? So for 3321, if I start, let's say if I start with 50, 50 square will give me 2500. If I start with 60, 60 square will give me 3600. I want smaller number than this, so let me try it with 55. So if I use 275, 275. So 3025, little bigger number than this. Let me try it with the 56. 633. So 3696. I'll need a smaller number, but 55 and 56, 30 and 36, it's somewhere between it, right? And I may say it's greater than 55 and it's lesser than 56. So you may take again here 55.5, or even if you take 55.4, or even if you take 55.6 or 7, right, it's going to give you a very close answer. So this is how the approximation method works. It is very well applicable to the CBSE level. CBSE is not allowed calculators in 11th and 12th. For ICSE level, 11th, 12th calculators are allowed. 9th, 10th it is not allowed. So you can use this method, right, in case if the square root is a part of some bigger question. Approximation method will work only till 4 digit. For 5 digit it becomes tedious, right? It will again it will consume time. So if you are required to find the square root of 2 digit, 3 digit up to the 4 digit, the approximation method is very well suitable.